Okay, welcome back. So this should be the last part of the lecture for chapter 4. So part 4, the part 4. I didn't want to give you a part 3 that would have ended up being 45 minutes to an hour. It might already be 40 minutes. I'm not sure. I wasn't keeping an eye on the clock, but this is part 4. So here on this, what's going to happen on this particular slide, and maybe the next one, I might do on the next one as well, is just to walk through those steps again, okay? Walking through the steps for getting the standard deviation. So remember, in this particular slide example, or whatever you want to call it, it's not calculating everything out for you, but those steps are still there, all right? But remember, for step 1, you have to subtract the mean from each score, but you're not automatically given the mean. So again, how do we calculate the mean? Well, we have these homicide rates here, each of the scores. The sum of those scores is 13.6. That's what we have right here, 13.6. We know that we have 1, 2, 3, 4, 5 scores. If we come over here, we can see the calculation, 13.6 divided by 5. That means our mean is 2.72. So remember, step 1 of getting the standard deviation is to subtract the mean from each score. So real nice and handy, I'm going to subtract 2.72 from 3.6. So what I want you to do is take a moment, take out your calculator, and just test it out. Go ahead and do it. 3.6 subtract 2.72. You should get 0.88. Then if you just go down and you do the same thing, 2.72. This will be good practice for you. 0.72, subtract 2.72, and then subtract 2.72. And you should get all of these numbers. So I'll do one more, then I'll let you do them on your own. 3.2 subtract 2.72. I got 0.48. So take a moment and practice that, okay? If you want, pause the video. I will stop speaking for like 2 or 3 seconds to give you enough time to hit the pause button, but pause and work through that. See if you get that, if this is what you get. And then if you get all of these numbers, add them together, okay, to make sure you get 0. Remember though, just add them together. If you don't get 0, you might want to go back and revisit some of the information in the basic math prologue about adding and subtracting negative numbers. Okay, so it took me a little bit longer than a couple of seconds because I went ahead and added the numbers up myself as well. So, and I got 0, just so you know. One thing I want to point out for those of you, maybe if you ended up with some really odd number like 1.96, remember what you're doing here is you're taking 0.88 plus 0.48 plus 0.08. Then you get, I don't remember what the number was, but you get a number. Then you subtract 0.52 from that number. And at that point, you should have 0.92 positive. And when you subtract the next 0.92, you'll end up with a 0. So just in case, if you came out with a number like 1.96 or some weird number like that, that might be why you got that. So go back and try that again, in case for those of you that may have gotten a weird looking number. But your number at the bottom should, for the deviation for this particular column right here, that number should always be 0, okay? So remember, This is, let's see here. This is, so this is step 1, okay? And this is how you get the deviations. Then step 2 is you square those. So you take all of these numbers, now that you've gotten 0, and you square them. That's what you're gonna get over here, okay? My little arrows aren't all that pretty, but you get the idea, okay? So if you take 0.77, maybe you don't have a calculator that has the square, all you need to do is just take 0.77, multiply it by 0.77, and you should get, excuse me, I'm sorry, I was looking at the wrong number. You should take 0.88, square it, or you can do 0.88 multiplied by 0.88, and you should get 0.7744. Well, remember, excuse me, our default is to round up to the second decimal place. And since 0.7744, the 4 is below 5, so you're not going to round up to the next number. Do the same thing with 0.48. 0.48 squared is going to be 0.2304. 0.08 squared is going to be 0.0061. So I'm going to show you what, because this is one that you're going to round up. So 0.08 squared is going to be 0.0064. And remember, we only want to get to this decimal place. This is the second decimal place right here. Second. I know my handwriting is horrible, but the third decimal place that's right after the second one, that number is above 5. So we round this up. So this then becomes 0.01. That's how we get that number there, okay? So negative 0.52 squared becomes 0.2704. And when you multiply a negative times a negative, it turns into a positive, okay? That's how you end up with this number 202.13, right? Now here, they've gone ahead and continued the calculation. Remember on the previous example, it didn't do all of that. So step 1, and this is starting to get a little messy. Step 2, then you sum everything. That gives us step 3. All right, so when we come over here, we do the calculation. We take, because remember, step 4 is we divide the sum of the squared deviations by n. This is that sum of those squared deviations. So this is step 4. Then this is step 5. So practice those calculations. Check and see what you end up with when you do that. Let's see here. 0.43. Take the square root of 0.43. And you should end up with, once you do that, this is what you end up with. 0.6557 if you go all the way out to the 4th digit. Well, when you round that up, that should be 0.6, because this 5 is going to turn that into a 6, okay? And that's how you end up with 0.66. So for this particular sample, or this one right here, the 5 New England states, the standard deviation is 0.66, okay? I'm not gonna go through all of that again, other than just writing the steps. So let's see here. I'm not gonna write all of these, I'm just gonna do one of them. So subtract 4.38 So there's step one. All right. Then remember, you take these and you square these deviations, because remember the deviations, it's the you take the 6.4 minus 4.38. So you subtract the mean from the score, and then that number that you get, that's the deviation. Then you take that and you square that. That's going to be step two. That's the outcome right here. That's what that outcome is. Then this sum, that's step three. Okay. Over here, this is step 4. This is step 5. Then you get your number. All right. So in looking at that, before I move on to the next slide, remember for the 5 New England states. So the 5 New England, whoops, forgot a letter there, folks. Moving a little too fast. Okay, let's try that again. Okay, so for the 5 New England, you guys get the point. 5 New England states, it is equal to 0.66. For the 5 Western states, it's equal to 1.73. So at this point, if you remember, hopefully you remember, the larger the standard deviation, the more variation within the scores. So the 5 Western states, there's more variation in those scores, okay? All right, moving on to the next one. Here, we don't need to calculate anything. They've pretty much given us the information that we need. What this really is looking at is interpretation. That's really what we have going on with this particular slide. Let's see here. Let's change. I'll go ahead and just do yellow this time. Okay, so again, like I said, we don't need to calculate anything. We already have the mean. Okay, that's what's going on here. We have the standard deviation. All right, so we have the mean, we have the standard deviation. That's what that S stands for both maternal engagement and paternal engagement. So remember, again, remember the X with the bar on top is the mean for each distribution, and lowercase s is the standard deviation for the sample. Now, what I want to do, I think I've gone over the symbols enough to where hopefully you remember and can recognize these symbols, but there are a few things in the table that I want to point out. There we go. There are a few things that I want to point out. So in looking at this and in reading this, you have some information here, and I just want to make sure you are able to read it correctly. You have the 1-year-old and the 3-year-old columns under each type of engagement. So you have your maternal engagement. So basically, how involved or how engaged is the mother with the children, okay, based on the age of the child and their marital status. So this row right here is for all the married folks, okay? This is all the this is all of the married people. So maternal engagement, the engagement of mothers that are married, but then you have the engagement with their children of mothers that are cohabitating with the father. So basically they're living together. So married versus living together when the kid is 1 year old, the maternal engagement. Maternal engagement with the 3-year-old child of a mother who's married versus a mother who's just living with the child's parent, the child's father. In this instance, they're using maternal and paternal engagement. And then you got the same thing going over here, but instead of maternal, you have paternal. Okay, you have fathers. How engaged are the fathers with the child? And so what the mean score is telling us, you know, what the mean score. So like in the first one, in the married, for the 1-year-old, the mean score is 5.3, whereas for cohabitating, it's 5.23. Well, what that's telling us is for a married woman with a 1-year-old, the mean score for maternal engagement is higher than the mean score for those women cohabitating with a 1-year-old. This means that maternal engagement is higher among married women with a 1-year-old, right? Now, even though we could make the statement that maternal engagement is higher among married women, it's also important over here to look at the standard deviation, because this lets us know about the amount of variation there could be in the scores. So although the maternal engagement among married women is higher, so is the standard deviation score, okay? That basically means there's more variation here in this particular score than there is with this one, even though it's showing us that maternal engagement is lower amongst those women that are cohabitating. It's one of those where we might want to think about the numbers again, because the standard deviation, the variation in the scores is lower, and that's going to be what we want. That really comes into play in a situation like what we have over here with the fathers. These scores are really, really close, a little closer than the scores for maternal engagement. But if you look at the standard deviation, there's a significant amount of difference in those standard deviations. Even though, you know, over here, up here, the score is lower, just slightly, but that standard deviation is really high in terms of, in relation to the fathers that are cohabitating, all right? So hopefully that makes sense, because what the ultimate question is, and this is why we look at standard deviation and why we have this, we're wanting to understand or answer the questions, how does maternal engagement compare to paternal engagement for married men and women? So in this instance, you could actually look at, you don't have to look at just the maternal engagement between married and cohabitating women. You could actually look at maternal and paternal engagement for married men and women. So you could look at maternal engagement for a married woman with a 1-year-old versus paternal engagement for a married man with a 1-year-old. And you'll see that the maternal engagement, the mean is higher, and there's less variation because that standard deviation score is lower. Whereas the paternal engagement is lower and that standard deviation is higher than it is over here. So that's what's being looked at. So what I would say do is maybe take a moment and see if you can figure out how to answer that question, especially for the second one. How does maternal engagement compare to paternal engagement for cohabitating men and women? See if you can answer it. Actually, I'll tell you what, see if you can answer this, and I will offer you, if you answer it and you get the question correct, I will give you 5 extra credit points on an assignment of your choosing. So that can be assignment 1, 2, 3, or 4, or that can be one of the quizzes, okay? So I will make a note, and I will set up something in Canvas to get to that, to be able to, where you can upload that and submit that. So 5 extra credit points, or 5 points if you answer this question. Answer question number 2, okay? Uh-oh. Sorry, my pen is not doing what it's supposed to do. If you answer question number 2, so answer this one, and you can get 5 extra credit points. If you answer it correctly, you can't just give me some answer. You have to answer it correctly so I can see if you understand how the two compare. Remember, keep in mind, even if the mean is higher, you might not want to have a whole lot of variation in the scores. So, you know, giving me that information will be beneficial. Okay. All right. So moving on to the next thing. Oh, I went backwards. Okay. So at this point, I'm looking at what we're looking at now is box plots. To this point, we've looked at numerical methods to analyze dispersion. However, box plots and whisker plots allow researchers to visualize dispersion. A box plot is basically a graphical technique that is based on 5 descriptive measures, and that's the smallest observation, the first quartile, the median, the third quartile, and the largest observation. The box plot provides a helpful way to visualize and analyze dispersion. Some people, the numbers just don't work for some people. That's just really hard for some folks. Some people are more visual, and seeing something like what you see on the screen right now works better for them. For me, I can look at both, but I actually prefer looking at the numbers. That just works a little better for me. But sometimes it is helpful to look at a box plot. Now, essentially, a box plot is defined as a graph that presents information about central tendency and dispersion of a variable. The box plot, again, consists of a box and 2 lines, one to the left and one to the right of the box, or in some cases vertically. So as you can see right here, the cases are vertical. The box stretches from the first quartile on the left to the third quartile on the right. Again, in this instance, it's going vertical. The left or bottom whisker extends to the smallest observation inside the lower limit. So here's the smallest observation right here. And then the right or the top whisker up here extends to the largest observation within the limit, okay? So, and then 2 horizontal lines extend from the box. The 2 horizontal lines extending from the box in the box plot are called the whiskers. The 2 whiskers span the range of non-outlier scores. An outlier is basically defined as any score that falls outside the whiskers of the box plot. So if you have, let's say you have a score, let's say you have a score of 90 up here. That would be an outlier, okay? Because it falls outside of the whiskers on the box plot. These are the whiskers right here. Okay, that is, yeah, those are the whiskers. Yeah, let me stop there. Those are the whiskers. So with regards to the whiskers, the left and right whiskers extend to the smallest and largest observations that are no further from the edge of the box than what is called the lower limit and the upper limit, okay? The lower limit is 1.5 times the height of the box below the first quartile, and the upper limit is 1.5 times the length of the box above the third quartile. This right here is just kind of me giving you information. You know, it's kind of starting to get a little technical at this point, but basically what you need to know and understand with this is it's another way to demonstrate and provide a visual representation of the information for dispersion. Let's see here. For this particular slide, like this has all the information that we've covered to this point in the lecture. So I want to highlight a few things. Okay, so we've got, remember, for range, we needed that low score and that high score. 46 minus 23 gives us 23. So we've got the range. All right, so remember, that's the first one that we looked at. Then we have I'll do orange next. Then we have the interquartile range. That's Q1, Q3, and then we've got that number. So Q3 is 43, Q1 is 34, 43 minus 34 is 9. So now we have our interquartile range. And then remember, the very last thing that we looked at is standard deviation. Okay, so standard deviation, we've got that right there. That is basically, again, the distance from, that's the number of deviations or standard deviations away from the mean. And if you look at the standard deviation, so we're given I only highlighted it for the first one, but if you look across, we're given that information for each one of these. And one of the things that you'll notice when I go to the next slide, because the next slide is going to actually have the box plots, you're going to notice that the size of the box plots corresponds to what you see right here. Okay, so let's go ahead and go to that next slide. All right, so for the high income, so we're over here with high income. Remember, the median over here was 11. And if you look at where this bar in the middle, inside of the box, it's about where the 11 mark would be, okay? Standard deviation is 3.4. So when you look at how far away these items are from 11, they're not that far, because the standard deviation for this one is really small. And you notice the box itself is small. The whiskers and all the stuff that go along with it, they don't extend out that far. But then if you look over here, remember lower to middle income, that's the one, I think it had the second highest standard deviation, if I remember correctly. Yes. Lower middle income actually had the highest standard deviation, excuse me. Low income had the third highest, and upper middle income had the second highest. But if you notice, look at how far out the whiskers are, and look how long or how tall, if you will, the box plot is. And think about those measures of dispersion. The standard deviation, again, for this one is 8.9. The median is 28, and the standard deviation is 8.9. So when you look at that, you see how far out it extends. And all this is just a visual representation of that information that appears here on this particular slide. That's all the box plot is. It's a visual representation of this information right here. Okay, so for this, this is just basically a summary, if you will. It's summing up some of the main information that that I've given you throughout this particular lecture. You know, if you have a range, or if you have an interquartile range score or a standard deviation score, the higher it is, the more diverse the group, the more diverse your sample or your population is going to be. And that typically is going to be the case when you have larger samples and larger populations. The more people you have, the more diversity you're going to have. But as those numbers go down, the diversity tends to decrease, or the variety decreases. And this is going to be the case when you have smaller samples, or when you have samples where the groups tend to look alike. So more homogeneous, excuse me, groups, you're not going to have as much diversity. And again, the lowest possible value for R is 0. That basically means there's no dispersion, there's no variation within that score. Doesn't happen very often, but it is a possibility. Well, that concludes this particular portion of the lecture. It ended up being a little bit longer than I wanted it to be, but hopefully me going through and demonstrating some of the stuff that I demonstrated was helpful to you. If you felt like it was helpful, just give me some feedback and let me know. If even after viewing this, you need to see more practice problems, let me know that as well. And I will try to go through and come up with a few more practice problems where you see me walk through the steps. But on that note, have a nice day. As always, ask me questions, email me if you have any questions or concerns, and I will get to them as soon as I possibly can. You're also welcome to put any questions related to the content in the Ask Your Instructor discussion board. Take care.